यस, गुड आफ्टरनून। लास्ट टर्न पे हम लोगों ने चॉपर शुरू करा था और उसमें बक और बूस्ट चॉपर के बारे में देखा था. In the previous lecture, we have seen about buck and boost chopper. As we know that these choppers are used for to control the speed of DC motor as battery charger, as well as for the provide the DC link for inverter if it is external control. Right, all those things we have seen in our previous lecture. Today we will see the analysis of buck chopper. Right, how to calculate the instantaneous value of current, what should be the ripple in that current, and what should be the output voltage if the current is continuous or it is discontinuous. All those things we will see in today's lecture. Right, so as we have already seen that the buck chopper, this is the switch. Let me mark it as switch. Right, once the switch is on, it will give you output as VDC, and when it is off, the current is circulate through the freewheeling diode and you will get the zero output voltage. And this is how we will calculate the average output voltage. This is the value of average current, which is equal to average output voltage divided by resistance. So it is come out to be alpha VDC by R. Similarly, we can calculate the RMS output voltage, which is V 1 by T, 0 to T, V square dt, and the under root of the entire quantity, right? So this will give you that RMS output voltage is proportional to under root of alpha. Clear? Whereas average is proportional to alpha. Likewise, if we talk about the effective input resistance, it is come out to be average DC voltage divided by current, average current. So it is come out to be R by alpha. Means from fixed resistance we can have the variable resistance. This concept is also used when we talk about the static rotor resistance control in case of induction motor. That is different thing. We will discuss someday about this afterwards. Now the case second is when this is the RLE load, means now it could be continuous, it could be discontinuous or critical continuous. If it is a critical continuous or continuous, the output voltage is alpha VDC, but if it is discontinuous, then waveform has to be changed. You can see during the T on period, the current is increases and output voltage is VDC, and when the freewheeling, the current is slowly decreasing. Current is slowly decreasing. At this instant it is off. This is the freewheeling period. Means during this period, let me mark, during this period switch will conduct, and during this period your freewheeling diode will conduct, right? This freewheeling diode would conduct during this period. Right, so average output voltage can be calculated using volt time balance equation. Average output voltage multiplied by the time period is equal to VDC times T on this voltage plus E times this time, E multiplied by this time. How much it is this time is? This the entire period is T off minus T freewheeling. T off minus T freewheeling would give you the average output voltage. It is quite obvious when the current is discontinuous, the average output voltage is increased by T off minus T freewheeling divided by T times E. E is the back EMF. So before finding the output voltage, we have to find the nature of current. We have to find the nature of current. It means when this current is continuous, it will give you alpha time VDC. When it is discontinuous, you have to find out accordingly. Now let us assume the current is continuous. So there are two mode of operation. Means when switch is on, current flows through the source to load. This switch is on, current flows like this, and when this switch is off, current freewheel through this circuit. So there are two modes, when switch is on and when switch is off. During off period, current flows through freewheeling diode. Now the basic equations can be written like this. When the switch is on, current under steady state, it go from minimum to maximum value, and when it is off, it go from maximum to minimum and cycle repeat. So if we write the basic KVL equation, V0 is come out to be Ri0 plus LdI0 by dt plus E. And the solution of this first order differential equation can be easily found out by steady state and transient state component. Once we add this steady state component, which is VDC minus E by R, and the transient state component, which is A e to the power minus T by tau, where tau is equal to L by R. That is the time constant of machine. Clear? You can notice at T equal to 0, current is I minimum, and when T equal to 1, the current is at its maximum value I max. After putting these value at T equal to 0, I0 equal to I min, we get the value of A. Once you have this constant, you can find out the instantaneous value of current during on period. Mind it, it is applicable only for the duration of 0 to T on. 0 to T on. This. Clear? Now, if we talk about the next duration, that means not next duration, at T equal to T on, the value of current is I max. Once we put these two things here, what we get, I max is come out to be VDC minus E times 1 minus T on by tau plus I min E to the power minus T on by tau. This we get, means maximum current comes out in the term of minimum current and various circuit parameter RLE and T on and tau. Right? Likewise, for T of period, this current is circulating through the freewheeling diode in the load RLE, and this is the freewheeling diode. And it is go like this. Now apply the same KVL, we get the steady state is VDC minus I, but here VDC is 0, so it has come out to be minus E by R, and the transient state is come out to be A dash E to the power tau dash by tau. Now by applying the boundary condition, that means at T dash equal to 0, I0 is I max. This is simply 0 shifting. We have shifted our T from here to here, T dash. So here T dash is 0, that means here current is maximum. So from here we will start and we will get the value of I min is come out to be minus E by R 1 minus E to the power T off by tau plus I max E to the power T off by tau. This is equation number 2. Now from equation number 1 and 2, we can find out the value of I max in terms of supply voltage, circuit parameter like R and L by R, that is tau, and the switching frequency T, and the duration of on period, or you can say the duty cycle, and back EMF E or DC voltage E. Similarly, I min is come out to be this. Now, once you know the value of minimum current I min, if this current is 0, that means it is the case of critical continuous condition. Or if this current is come out to be negative, that means it is discontinuous mode of conduction. Someone can ask, find out the value of inductor. So you can use this expression for I min. Put here I min is equal to 0 and found the value of tau. Once you have the value of tau, tau is equal to L by R. If R is known, you can find out the value of L, for which this current is just continuous, critical continuous. Clear? Now if it is come out to be negative, that means what? It means the current is negative. It cannot be possible to have negative current. The only meaning is that the current is discontinuous. Now once we have I max and I min, you have to find out the value of ripple current. Ripple current is I max minus I min. just minus I min from I max, you will get delta I is come out to be like this. Here alpha t is what? Alpha t is basically T on, because alpha is equal to T on upon T. Therefore alpha t is equal to T on upon T into T. T get cancel out, T on. Likewise T off is written as 1 minus alpha times T. This 1 minus alpha is 1 minus T on upon T into T. So T minus T on upon T into T. This T get cancel out. T minus T on is equal to T off. So T off is written like this. Now just only the term which is variable in nature is alpha. So just differentiate this. So just differentiate this. We will get alpha is come out to be 0.5. If duty cycle is 50%, then the ripple would be maximum. And if duty cycle is less than or greater than 50%, then ripple is not maximum. They are less than the maximum value. And what should be the value of this maximum ripple? As delta I max is given by VDC by R times 10 hyperbolic R upon Fi. How it comes? You just put the value of alpha is equal to 0.5. If you put this value here, you will get the function of this. Small correction. This. It is equal to I max plus I min is here. Now you have to find out the value of I max I minus I min, and this value is come out to be this. This value is come out to be VDC upon R 1 minus, let me take the green color, just give me a second. You have to subtract I max minus I min. When you do this, you will get the value of this is come out to be 1 minus e to the power t by r by tau plus e to the power minus t by tau minus e to the power minus 1 minus alpha times t by tau. 1 minus alpha times t is equal to basically equal to t off, and divided by 1 minus e to the power minus t by tau. 1 minus e to the power minus t by tau, right? That you will get. Now after differentiate this, you will get alpha is equal to 0.5, and when you put this value here, you will get the value of delta I max is come out to be delta I max is come out to be this. Delta I come out to be this. Clear? It is at duty cycle 0.5. So as we know that for when this 4FL, this is greater than R, then this value is very small, and for a small value then hyperbolic theta is come out to be theta. So delta I max is come out to be VDC divided by 4FL. That we will get, right? Now if you want to make this constant, what you have to do, you have to make the motor time constant is greater than the time period, sitting time period, right? Means that this total time must be greater than the time constant of the motor, that is L by R must be greater than this time, right? T on plus T off, T on plus T off. Now for this continuous mode of conduction, just calculate the period of this. For this, what we have to do, again we have to write this the equation VDC is equal to RI0 plus LDI by 0 by dt plus E, as I min is 0 because every time it is coming at 0. So I0 is come out to be this. By you can have this value by simply putting here I min is equal to 0. Here you can see this I min is equal to 0. Once I min is equal to 0, this value is come out to be this. Likewise, when you apply that t at t equal to t on, I is equal to I max, so you will get the value of I max. Similarly, for the freewheeling period, again this value start from I max and come to 0. This is 0, this is I max. So applying those things, we will get the value of I0 as minus E by R, 1 minus e to the power minus t dash by tau plus I max e to the power t dash by tau. We know at t dash equal, everything is clear. In case if you have any problem, you can write in the comment box. Also, you can do the direct message to me. I'll try to solve. I'll try my level best to make your fundamentals clear in the field of power electronics. Thank you. Bye bye. Keep on studying.